Seen through a telescope, Uranus barely does anything. No swirling storms like Jupiter, no dramatic rings glowing like Saturn's, just a flat, pale blue-green disk sitting quietly in the dark. For most of the time we've known it existed, that stillness made Uranus feel like the least interesting planet in the solar system. But appearances, in this case, were deeply misleading. Underneath that calm exterior, Uranus turned out to be one of the most physically deranged planets we've ever encountered. And we only found out how deranged because of one brief, almost accidental visit from a spacecraft that wasn't even built specifically to study it. That spacecraft was Voyager 2, and the year was 1986. It remains, to this day, the only machine humanity has ever sent close enough to Uranus to actually examine it up close. Everything else we know comes from telescopes staring at it from hundreds of millions of miles away. So when Voyager 2 swept past for a matter of hours, it wasn't topping off an already well-understood picture of the planet. It was writing the picture from scratch, and what it wrote didn't look anything like what scientists expected. Start with the most visually obvious problem. Nearly every planet in the solar system spins in roughly the same orientation, upright, with its axis pointing more or less out of the plane in which it orbits the Sun. Earth leans about 23 degrees off vertical. Even Saturn, with its huge tilted rings, only leans around 27 degrees. Uranus leans 98 degrees. That's not a tilt anymore. That's flipped over. Picture a spinning top that's fallen onto its side and kept spinning anyway, rolling along the table instead of standing upright. And you have a pretty good mental image of how Uranus travels around the Sun. Because of that extreme lean, the seasons on Uranus don't work anything like the seasons on Earth. One pole spends roughly 21 uninterrupted years bathed in continuous sunlight, while the opposite pole sits in total darkness for the same stretch. A person born at the start of a Uranian summer at one of the poles could grow into adulthood without ever seeing the sun dip below the horizon. Meanwhile, near the equator, the sun rises and sets twice a day in a strange double cycle as the planet's sideways orientation warps the usual day-night rhythm entirely. Nobody has directly observed what caused this, but the leading theory, and still the one most planetary scientists favor, involves violence early in the solar system's history. Somewhere in Uranus's infancy, something enormous, possibly an object approaching the size of Earth itself, is thought to have slammed into the young planet. An impact on that scale carries enough raw momentum to physically knock a forming world onto its side and permanently alter the direction it spins. Some scientists lean toward a single catastrophic strike. Others suspect a string of large impacts that gradually tip the planet further and further over time. What makes this theory compelling isn't just the planet's tilt, though. It's that Uranus's rings and moons orbit in that same sideways plane rather than the planet's original orientation, meaning whatever knocked Uranus over also dragged the material surrounding it into the same lopsided arrangement, evidence of an event violent enough to reshape an entire miniature system, not just one planet. That's the mystery you could work out just by watching how Uranus moves. Voyager 2 was designed to dig into something you can't see with a telescope at all, and when its onboard magnetometer began collecting readings as the spacecraft closed in, it picked up something that didn't match any planet examined before it. Every planet studied up to that point generated a magnetic field that lined up reasonably closely with its spin axis, the way Earth's magnetic pole sits fairly near its geographic pole. Uranus broke that rule entirely. Its magnetic field sits a full 59 degrees away from its rotational axis, and it isn't even centered inside the planet. The source of the field appears to be shoved off-center by roughly a third of Uranus's radius, sitting well away from the planet's actual middle. Think about what that would mean on Earth. Instead of the magnetic North Pole sitting near the geographic North Pole, imagine it showing up somewhere over the Sahara, generated not from the planet's core, but from some point shifted far off toward one side. That's roughly the scale of dysfunction. Voyager 2 measured at Uranus. Combine that lopsided magnetic axis with a planet that's already lying on its side, and you get a magnetic environment that essentially wobbles and twists chaotically with every rotation, described by some researchers as behaving like a corkscrew, spiraling unpredictably out into space, rather than forming the tidy, symmetrical shape seen at most other planets. Later analysis even suggested the whole magnetosphere flickers open and shut on a kind of daily switching rhythm as this crooked field spins and collides with the stream of particles constantly flowing outward from the Sun. For decades, this was treated as one of the fixed, defining facts about Uranus, hard proof that whatever machine generates its magnetic field works completely differently from the metallic cores that power fields at Earth or Jupiter. Current thinking points toward a slushy, electrically conductive layer buried somewhere in Uranus's mantle, made of compressed water, ammonia, and methane, a layer too unstable and irregular to produce the clean, centered field found elsewhere. But there's a fascinating wrinkle here, too. Scientists revisiting the original 1986 data years later found evidence that Voyager 2 might have caught Uranus's magnetic Field, in an unusually squeezed, compressed condition, the result of a strong burst of solar particles that had arrived just days before the flyby, a set of conditions estimated to occur less than 5% of the time. Arrive at Uranus a few days earlier, and Voyager 2 might have recorded a noticeably calmer, less extreme magnetosphere. The bizarre tilt and off-center nature of the field don't go away because of this, but it's a reminder that essentially everything we know about how this planet's magnetism behaves is built on one short encounter that may not have even caught the planet in a typical state. The magnetic field wasn't the only surprise waiting in the space around Uranus. Before Voyager 2 arrived, astronomers knew of only 5 moons orbiting the planet. The spacecraft's cameras spotted 10 entirely new ones in the data it beamed home, more than doubling the known moon count from a single flyby. Decades later, researchers digging back through the archived Voyager 2 data found evidence of yet another previously overlooked moon. Combined with additional discoveries made using ground and space-based telescopes since then, Uranus is now known to have somewhere around 28 moons circling it, an entire miniature system tucked around a planet lying on its side. One of the smaller moons Voyager 2 photographed for the first time, a dark, heavily battered little world barely 100 miles wide named Puck, showed a surface so pockmarked with craters that it resembles the surface of a golf ball, evidence of billions of years spent absorbing impacts. But the bigger surprises came from the moons astronomers already knew existed, ones nobody had ever actually seen up close until Voyager 2 got there. Chief among them was a small moon called Miranda, and what the spacecraft found on its surface remains one of the strangest sights photographed anywhere in the outer solar system. Miranda's surface isn't a single consistent landscape. It's a jumbled collage of completely different terrains jammed together, smooth flat plains sitting directly beside enormous grooved and ridged formations, with cliffs plunging for miles straight down, dwarfing anything found on Earth. For a moon, only a few hundred miles. Across to display that kind of violent patchwork geology suggests it may have been blasted apart by a massive impact at some point, and then slowly pulled itself back together under its own gravity, its shattered fragments fusing into a surface unlike anything else we've documented. Then there were the rings. A faint set of rings around Uranus had already been detected from the ground back in 1977, discovered almost by accident when astronomers noticed a distant star flickering as unseen material passed in front of it, while Uranus crossed its path. But nobody had actually laid eyes on those rings, directly until Voyager 2 arrived. The spacecraft confirmed the rings astronomers had already inferred and found 2 more that nobody had known about, narrow dark bands made from a mix of fine dust and boulder-sized chunks. Unlike Saturn's bright, wide, icy rings, Uranus's ring system is dim and nearly black, likely, composed of material darkened over billions of years by constant radiation exposure. Exactly how these rings came to exist is still debated, whether they're the shattered remnants of a small moon torn apart by gravity, or leftover debris from whatever ancient collision may have tipped Uranus onto its side in the first place. And then there's the atmosphere, the thing responsible for that pale blue-green glow visible from Earth. Voyager 2's instruments confirmed that Uranus's atmosphere is mostly hydrogen and helium, similar to the composition found at Jupiter and Saturn, laced with a small but critical amount of methane gas. Hydrogen and helium, similar to the gas giants Jupiter and Saturn, but laced with a small but crucial amount of methane. That methane is the key to the color. It absorbs red light and reflects blue and green wavelengths back out, giving Uranus its signature pale cyan tint, distinct even from its near twin planet Neptune. Beneath that upper haze, scientists suspect there are also clouds containing hydrogen sulfide, the same compound responsible for the smell of rotten eggs, meaning that if you could somehow survive the crushing pressure and lethal cold long enough to take a breath, Uranus would smell genuinely foul. Speaking of cold, Voyager 2's readings confirm something else strange about this planet. Uranus is the coldest planet in the entire solar system, colder even than Neptune, which sits much farther from the Sun. Temperatures in its upper atmosphere can plunge below minus 220 degrees Celsius. That's especially strange. Because every other giant planet we've measured radiates noticeably more heat out into space than it absorbs from the Sun, evidence of leftover heat still escaping from their formation billions of years ago. Uranus barely does this at all. Its internal heat output is puzzlingly almost non-existent, and nobody has ever fully explained why. One leading idea ties this mystery directly back to that ancient, sideways tipping collision, theorizing that the same violent impact that knocked the planet over might have also disrupted its internal structure in a way that trapped heat deep inside, preventing it from convecting up and radiating away, the way it does on Jupiter, Saturn, and Neptune. In other words, the same cosmic accident that gave Uranus its bizarre tilt might also explain why it's the coldest world in the solar system. A chilling twist for a planet that otherwise looks so calm from a distance. Taken all together, what Voyager 2 revealed at Uranus in that one brief flyby, lasting only a matter of hours as the spacecraft raced past at tens of thousands of miles an hour, painted a picture of a planet that is anything but boring underneath its quiet blue-green surface. A world tipped completely on its side, likely thanks to an ancient, near-catastrophic collision. A magnetic field so lopsided and off-center that it behaves almost nothing like any other planets. A collection of moons, including one, Miranda, that looks like it was shattered apart and stitched back together. A dim, dark ring system unlike anything else in the solar system. And an atmosphere that's not just strange in composition, but strangely, mysteriously cold, holding on to secrets about the planet's interior that we still don't fully understand. And here's the thing that makes all of this even more remarkable. Every single one of these discoveries came from one spacecraft, on one flyby, in January of 1986, using instruments that are now decades old by modern standards. Voyager 2's wasn't even designed primarily to study Uranus. It was on what's often called the Grand Tour, a rare planetary alignment that let a single spacecraft swing past Jupiter, then Saturn, then Uranus, then Neptune, using each planet's gravity to slingshot itself. Onward to the next. Uranus was essentially a brief stopover on the way to somewhere else, and yet it managed to upend decades of assumptions in the space of a single close pass. It's worth stepping back for a second to remember just how recently Uranus even entered human awareness at all. Unlike Mercury, Venus, Mars, Jupiter, and Saturn, which have been visible to the naked eye and known to astronomers since ancient times, Uranus wasn't identified as a planet until 1781, when the astronomer William Herschel spotted it through a telescope and, at first, assumed he'd simply found a new comet. It took further observation to realize this faint, slow-moving object was actually a planet, the first one ever discovered using a telescope rather than the naked eye. That alone tells you something about Uranus. It's so dim and so far away, roughly twice as distant from the Sun as Saturn, that even its basic existence as a planet went unnoticed for the entire span of recorded human history before that point. So when Voyager 2 finally arrived in 1986, it wasn't just filling in a few details about a well-studied world. In many ways, it was the first time humanity got any kind of real close-up look at a planet we'd barely had 2 centuries to even think about. It's also worth putting Uranus side by side with its closest relative Neptune because the comparison sharpens just how unusual Uranus really is. The two are often lumped together as the solar system's ice giants, similar in size, similar in general composition, both a strange blue color caused by methane in their atmospheres. Voyager 2 visited Neptune 3 years later in 1989 and found a magnetic field there that was also tilted and offset from center, though less extremely than at Uranus. But Neptune, unlike Uranus, radiates a very obvious surplus of internal heat, and its atmosphere is considerably more active, with visible storm systems and fast-moving cloud bands that Uranus mostly lacks, at least during the relatively quiet season Voyager 2 happened to observe it in. That contrast is part of why scientists remain so puzzled by Uranus specifically. It isn't just an ice giant behaving the way ice giants are expected to behave. It's the outlier even among the outliers, colder than it should be, quieter than it should be, and shaped by a violent past that we still can't fully reconstruct from a single flyby's worth of data. In the years since Voyager 2's visit, telescopes have continued to add small pieces to the puzzle, even without another spacecraft making the trip. The Hubble Space Telescope and, more recently, the James Webb Space Telescope have both captured detailed images of Uranus that reveal faint atmospheric bands, subtle storm activity, and a surprisingly bright polar cap that seems to shift with the planet's extreme seasons, hinting that Uranus isn't quite as static and featureless as it appeared to Voyager 2 back in 1986. Some of that quietness Voyager 2 recorded may simply have been bad timing. The spacecraft happened to fly past during the planet's southern hemisphere summer solstice, a season when atmospheric activity may naturally settle down, only for storms to pick up again as the decades-long Uranian seasons shift. Newer infrared images have picked up powerful storms and fast, banded winds that were essentially invisible during the Voyager 2 encounter. A reminder that one brief flyby, at one particular moment in an 84-year orbit, can only ever capture a single snapshot of a planet that changes dramatically over the course of its own extraordinarily long year. All of this is exactly why there's now a serious, active push within the planetary science community to send a dedicated mission back. Rather than another quick flyby, scientists are advocating for an orbiter, a spacecraft that could circle Uranus for years, along with an atmospheric probe that could plunge directly into the clouds and sample their chemistry firsthand, the way NASA once did at Jupiter. Such a mission has been identified as one of the highest priorities in planetary science for the coming decade, though it likely wouldn't launch until sometime in the 2030s, with a journey of a decade or more just to reach the planet after that. If it happens, it would be the first time in over half a century that a spacecraft gets a proper extended look at Uranus, rather than the fleeting hours Voyager 2 had to work with. Nearly 40 years later, no other spacecraft has ever returned. Everything we think we know about Uranus's magnetic field, its interior, its strange chemistry, and its ring system is still built almost entirely on data gathered during that one short flyby. Sometimes just a matter of hours of close-range measurements, some of which, as newer research suggests, may have caught the planet in an unusually extreme, non-typical state. That's why, in recent years, planetary scientists have been pushing hard for a dedicated new mission back to Uranus, a spacecraft that could orbit the planet for years rather than race past it in an afternoon, drop a probe into its atmosphere, and finally get a long, steady look at this sideways, lopsided, mysteriously cold world. Until that mission happens, everything we know about what's really going on inside Uranus still traces back to one extraordinary fleeting encounter decades ago when a small robotic explorer swept past a planet that looked calm from a distance and discovered it was anything but.